Hello, in this lecture we will find the value of A in two methods. In the drawing we have triangle ABC. We know that angle BAD equals to angle DAE equals to angle EAC, and all those angles are equal to alpha, and we know that the size of PD is 3 units, the size of DE is 4 units, and we also know that angle ABD is a right angle, it equals to 90 degrees, and we want to find out the value of EC, that is actually X. Okay, so we'll start with the first method. Actually, we have a rule about angle bisector. If we have triangle ABC, triangle ABC, and we know that AD is angle bisector of triangle ABC. AD, this line segment, is angle bisector, that is to say it divides angle BAC to two equal parts. That angle will be equal to theta, and this angle will be equal to theta. So AD is angle bisector because it divides angle BAC to two equal parts. AD is angle bisector. So the following relationship exists between the sides of triangle ABC. AB over BD equals to AC over DC. Okay, again, if you have triangle ABC and AD is angle bisector, then the following relationship exists between the sides of triangle ABC. AB over BD equals to AC over DC. Okay, so we will focus on triangle, the right triangle, triangle BAE. On this right triangle, triangle BAE, AD is angle bisector. AD is angle bisector. AD is angle bisector. So why AD is angle bisector in triangle BAE? Because it divides angle BAE, this angle, to two equal parts. That is to say, this, the size of this angle equals to alpha, and the size of this angle also equals to alpha. Therefore, the following relationship exists between the sides of triangle BAE: AB over BD equals to AE over DE. Again, in triangle ABE, the right triangle ABE, AD is angle bisector. Therefore, AB over BD equals to AE over DE. Okay? In the right triangle, triangle ABE, AB over BD equals to AE over DE. Here we will multiply this equality, we will divide this equality by AE, and then we will multiply it by DE. First of all, we will divide this equality by AE, AB over AE, and then we will multiply it by BD equals to BD over DE. Okay? AB over AE equals to BD over DE. What is the value of BD? BD equals to 3 units, so we will substitute BD by 3, and DE equals to 4 units, so we will substitute DE by 4. Okay, so we substituted BD by 3 and DE by 4, so in total we got that AB over AE equals to 3 over 4. Okay? AB over AE equals to 3 over 4. We will define, so we got this equality that AB over AE equals to 3 over 4. We will define AB as 3K. That is to say, AB equals to 3K, and we will find out what is the value of AE. So we'll substitute AB by 3K in this equality, and we will find out the value of AE. So AB is 3K over AE equals to 3 over 4. Here we will multiply this equality by AE. We will get that 3K equals to 3 over 4 times AE. We will multiply this equality by 4, and we will get that 4 times 3K is 12K equals to 3 times AE. Okay, here we will divide this equality by 3, and we will get that AE equals to 12K over 3 is 4K. So actually we found out that if AB equals to 3K, if AB equals to 3K, then AE will be equal to 4K. Okay? So we will continue to focus on the right triangle ABE. In the right triangle ABE, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square equals to AE square. Again, according to the Pythagorean theorem, AB square plus BE square equals to AE square. And what is the value of AB? AB equals to 3K. And the value of AE equals to 4K. Okay, so we will substitute AB by 3K in this equality, and we will substitute AE by 4K. And what is the value of BE? BE equals to BD plus DE, that is to say BE equals to 3 plus 4, that is to say to 7. So AB is 3K. So AB square will be equal to 3K square plus BE is 7. So BE square is 7 square. 7 square is 49. Equals to AE square. AE equals to 4K. Therefore, AE square is 4K square. So here, in this equality, 3K square equals to 9K square plus 49 equals to 4K square is 16K square. Here we will substitute from this equality 9K square, and we will get that 49 equals to 16K square minus 9K square is 7K square. So here we will divide this equality by 7, and we will get that K square equals to 49 over 7 is 7. So we got that K square equals to 7. So here we will take a root out of this equality, and we will get that K equals to the root of 7 units. K equals to the root of 7 units. After we found out the value, first of all, K equals to the positive root of 7, because K is the side of the triangle and it must be a positive number. Okay, so after we found out the value of K, we can substitute. We know that AB equals to 3K, so we can substitute K by root 7, because K equals to root 7. We will get that AB equals to 3 times root 7. AB equals to 3 times root 7 units. and AE equals to 4K, therefore, and K equals to root 7, so AE will be equal to 4 times root 7, or AE equals to 4 times root 7. So we found out the values of AB. AB equals to 3 times root 7 and AE equals to 4 times root 7 units, okay? So in the next step we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC, we know that tangents 3 alpha equals to BC over AB. Okay, tangents 3 alpha equals to BC over AB. What is the value of BC? BC equals to 3 plus 4 plus x. That is to say BC equals to 7 plus x. So we will substitute BC by 7 plus x. What is the value of AB? We have already found out that the value of AB is 7 times root 7 units. The value of AB is 3 times root 7 units. So we will substitute AB by 3 times root 7. Okay, so we found out that tangents 3 alpha equals to 7 plus x over 3 times root 7. So I will write it down. Tangents 3 alpha equals to 7 plus x over 3 times root 7 . In the next step, we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, this triangle, we know that tangents 2 alpha equals to BE over AB. Again, in the right triangle, triangle ABE, tangents 2 alpha equals to BE over AB. But what is the value of BE? BE equals to 3 plus 4. That is to say BE equals to 7. And we have already found out that AB equals to 3 times root 7. So we actually found out that the value of tangents 2 alpha equals to 7 over 3 times root 7. So I will write it down. Tangents 2 alpha equals to 7 over 3 times root 7. Okay, so in the next step we will focus on the right triangle, triangle ABD. So in triangle ABD, this triangle, we know that tangents alpha equals to BD over AB. in the right triangle, triangle ABD, we know that tangent alpha equals to BD over AB. What is the value of BD? The value of BD is 3 units, and we have already found out that the value of AB is 3 times root 7 units. So we found out that tangent alpha equals to 3 over 3 times root 7 units. Tangent alpha equals to 3 over 3 times root 7 units. So we actually found out the values of tangent 3 alpha, tangent 2 alpha, and tangent alpha. Okay? So we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha. Okay, tangent 3 alpha equals to tangent 2 alpha plus alpha. And in order to find out the value of tangent 2 alpha plus alpha, I will present to you a new trigonometric identity. Tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A times tangent B. Okay, so the value of tangent A plus B is tangent A plus tangent B over 1 minus tangent A times tangent B. So we will use this trigonometric identity in order to find out the value of tangent 2 alpha plus alpha. So the value of tangent 2 alpha plus alpha according to this trigonometric identity will be the value of tangent 2 alpha plus alpha according to this trigonometric identity will be tangent 2 alpha plus tangent alpha over 1 minus tangent alpha, tangent 2 alpha times tangent alpha. Okay, so the value of tangent 2 alpha plus alpha according to this trigonometric identity will be equal to tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha times tangent alpha. Okay. So in this equality, we will substitute tangent 2 alpha plus alpha, that is actually tangent 3 alpha, by the value of tangent 3 alpha, that is 7 plus 6 over 3 times root 7, and we will substitute the value of tangents 2 alpha by the value that we find out for tangents 2 alpha. It equals to 7 over 3 times root 7, and we will substitute the value of tangents alpha by the value that we have already found out for tangents alpha. Okay? And we will get that tangents 3 alpha, we have already found out that tangents 3 alpha equals to 7 plus x over 3 times root 7. It equals to tangents 2 alpha, and the value of tangents 2 alpha is 7 over 3 times root 7, and the value of tangents alpha is 3 over 3 times root 7, all divided by 1 minus tangents 2 alpha times tangents alpha. So we actually substituted the values of tangents 3 alpha, tangents 2 alpha, and tangents alpha by the values that we have already found out for tangents 3 alpha, tangents 2 alpha, and tangents alpha, and we got this equality. So here we will substitute 1 by 3 over 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7, and we will get that seven plus x over 3 times root 7 equals to 7 plus 3 is 10 over 3 times root 7, all divided by, we'll substitute 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. Okay, this expression is 1. Okay, minus 7 times 3 is 21. So actually in this way we got a common factor for these two expressions. Okay, and here we'll move this expression to the numerator and this expression to the denominator, and we will get that 7 plus x over 3 times root 7 equals to 10 times 7 root 3 times root 7 times 3 times root 7 over 3 times root 7. We will move this expression to the denominator. 3 times root 7, 3 times root 7 minus 21. So in total we got this equality. So here we have 3 times root 7 in the numerator, and we have 3 times root 7 in the denominator, so 3 times root 7 will get cancelled. And what is left after we cancelled 3 times root 7? Seven plus x over 3 times root 7 equals to, here we have 10 times 3 is 30 times root 7 over, here 3 times root 7, 3 times root 7 minus 21. Okay, that's what we got. Here we have 3 times root 7 times 3 times root 7. 3 times 3 is 9, and the root 7 times root 7 is 7, and 9 times 7 is 63. So this expression is equals to 63. We write it down. 30 times root 7 equals to 63 minus 21, and here we have 7 plus x over 3 times root 7. So we got this expression. So we have here 7 plus x over 3 times root 7 equals to 30 times root 7 over 63 minus 21 is 42. Okay, so we got this equality. So here we will multiply this equality by 3 times root 7, and we will get that 7 plus x equals to 30 times root 7. We multiply this equality by 3 times root 7. So here in the numerator of this side of the expression, we have 30 times 3 is 90, and root 7 times root 7 is 7, and 90 times 7 is 630 over 42 equals to 7 plus x. So here 630 over 42 equals to 15. So we will 7 plus x equals to 15. We will subtract from this equality 7, and we will get that x equals to 8 units. So the final answer to the question is that x equals to 8 units. Okay, x equals to 8 units. So here x equals to 8 units, so EC equals to 8 units. Okay, so we finished with the first method, and in the next step we will find out the value of x according to a second method. So we will find out the value of x according to a second method. So here we will make a construction. We will extend side BD by 3 units. Okay, we will extend side BD by 3 units. And we will define this point as point M. So we extended BD by 3 units, therefore MB will be also equals to 3 units. And then we will join together points A and M by a straight line. Actually, we know we extended BD by 3 units, so MD is a straight line. Okay, MD is a straight line, and we know that the sum of the angles in a straight line is equal to 180 degrees. So if we focus at point B on the straight line MD, we know that at point B at the straight line MD, the sum of the angles equals to 180 degrees. But we have already here 90 degrees. So 90 degrees plus the size of this angle must be equal to 180 degrees, according to the rule that the sum of the angles on a straight line is equal to 180 degrees. Okay? We can write here that if we focus at point B, we have here 90 degrees plus the size of angle ABM must be equal to 180 degrees, according to the rule that the sum of the angles on a straight line is equal to 180 degrees. So the sum of the angles at point B on the straight line MD must be equal to 180 degrees. So here 90 degrees plus the size of this angle ABM, must be equal to 180 degrees. Here we will subtract 90 degrees from this equality, and we will get that the size of angle ABM equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle ABM is a right angle, that is to say it equals to 90 degrees. Okay, then we will focus on the right triangle AMB and on the right triangle ABD. Okay, so in those two triangles A and B, and triangle ABD, the right triangle ABD, actually we will prove that those two triangles can join to each other. Triangle A and B can join to triangle ABD. Okay, first of all, according to our construction, we know that MB equals to BD equals to 3 units. According to our construction, MB equals to BD equals to 3 units. Okay, MB equals to BD equals to 3 units. And we also know that those two angles are right angles. That is to say, angle ABD equals to angle ABM equals to 90 degrees. We've already proved that angle ABM equals to 90 degrees. So we know that angle ABD, actually the fact that angle ABD equals to 90 degrees, it is given us in the question. Okay? Or angle ABD equals to 90 degrees. Okay, angle ABD equals to 90 degrees. Angle ABD equals to 90 degrees. It is given us in the question that angle ABD equals to 90 degrees. And we have already proved that angle ABM also equals to 90 degrees. So angle ABD equals to angle ABM, and those two angles are right angles. And AB is a common side, that is to say AB equals to AB. AB equals to AB. Actually, it is a common side, it belongs to both triangles. Okay, AB equals to AB, it is a common side. So we actually proved that triangle A and B congruent to triangle ABD according to side angle side rule. Okay, so I will write it down. Triangle A and B congruent, this is the sign of congruent to triangle ABM according to side angle side rule. Okay, so those two right angles congruent to each other according to side angle side rule. Actually, the side angle side rule is when you prove that the two sides and the angle between the two sides are equal to two sides and the angle between the two sides of the other triangle, then those two triangles will be congruent to each other according to side angle side rule. So we proved that those two sides and the angle between them are equal to those two sides and the angle between them in the other triangle. Therefore, those two triangles congruent to each other according to side angle side rule. Okay? So from the fact that those two right triangles can go into each other, we can conclude that angle MAB in triangle AMB equals to angle BAD in the right triangle BAD, and this angle actually equals to alpha. Again, from the fact that those two right triangles can go into each other, we can conclude that angle AMB equals to angle BAD equals to alpha, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? Corresponding angles in congruent triangles are equal to each other. Corresponding angles in congruent triangles are equal to each other. Actually, we know that those two triangles can go into each other, therefore the corresponding angles, that is to say those two angles, will be also equal to each other according to this rule. So if angle BAD equals to alpha, then according to this equality, angle MAB will be also equal to alpha. So the size of this angle is also alpha. And from the fact that those two right triangles can go into each other, we can also conclude that AM equals to AD. AM equals to AD. AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Again, AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is AM and AD, will be also equal to each other according to this rule. Okay, so AM equals to AD, and if we define AM as Y, if AM equals to Y according to our definition, then AD will be also equal to Y because of the fact that AM equals to AD. Okay, if we define AM as Y, then AD will be also equal to Y according to this equality, and in the next step we will focus on triangle ADC. So in triangle ADC, we know that AE is angle bisector. AE is angle bisector again in triangle ADC. AE is angle bisector. As you can see from the drawing, AE divides angle DAC to two equal parts. That is to say, to alpha plus this angle is alpha and this angle is also alpha. For that reason, AE is angle bisector of angle DAC. Therefore, according to the rule that is related to angle bisector, the following relationship exists between the sides of triangle ADC with the angle bisector AE. AD over DE must be equal to AC over EC. Okay, because of the fact that AE is angle bisector in triangle ADC, the following relationship exists between the sides of triangle ADC. AD over DE equals to AC over EC. But what is the value of AD? AD equals to Y according to our definition. What is the value of DE? DE equals to 4 units. All equals to AC over EC. What is the value of EC? EC equals to X according to what is given us in the question. So EC equals to X. So in total, we got that Y AD equals to Y, DE equals to 4, and EC equals to X. So Y over 4 equals to AC over X. We will multiply this equality by X. This will be our first equation. And we will get that AC equals to Y times X over 4. So according to equation number 1, AC equals to Y times X over 4. Okay, in the next step we will focus on triangle AMC. Okay, so in triangle AMC, we know that AD is angle bisector in triangle AMC. AD, the big triangle AMC, in the big triangle AMC, we know that AD is angle bisector. So why AD is angle bisector in triangle AMC? Because actually it divides angle MAC to two equal parts. The first part is alpha plus alpha, that is to say 2 alpha. This is 2 alpha. And the second part is also alpha plus alpha, that is to say to 2 alpha. So the reason that AD is angle bisector in triangle AMC because of the fact that it divides the angle MAC to two equal parts, that is to say to 2 alpha and 2 alpha. Okay? So according to the rule of angle bisector, the following relationship exists between the sides of triangle AMC that has angle bisector AD. That is to say, AM over MD equals to AC over DC. Again, AM over MD equals to AC over DC. Okay, according to the rule of angle bisector, the following relationship exists between the sides of triangle AMC, AM over MD equals to AC over DC. Okay? That will be our second equation. What is the value of AM? AM equals to Y according to our definition, so we will substitute AM by Y. What is the value of MD? MD equals to 3 plus 3, that is to say to 6, equals to AC over DC. What is the value of DC? DC equals to 4 plus X. So, according to equation number 2, we know that Y over 6 equals to AC over 4 plus X. Here we will multiply this equality by 4 plus X, and we will get that AC equals to Y over 6 times 4 plus X Okay, we got this. After we multiply equation number 2 by 4 plus x, we got that s equals to y over 6 times 4 plus x. But according to equation number 1, we have already found in equation number 1 that AC equals to y times x over 4. Okay? So, here we will create the third equation that states that AC equals to AC, AC equals to AC, so we have the equality that AC equals to AC. So here we'll substitute AC by the value of AC in equation number 1, and in the other side of the equality we'll substitute AC by the value that we found for AC in equation number 2. Okay? We will get that AC according to equation number 1 that equals to y times x over 4 equals to AC according to equation number 2, it equals to y over 6 times 4 plus x. So here we will divide this equation number 3 by y. We should remember that y is a side of the side of a triangle, therefore it can never be 0, so it is allowable to divide the equation by y, because y can never be 0. Okay, so we will divide the equation number 3 by y, and we will get that x over 4 equals to 4 plus x over 6. Okay, so here we will multiply this equality by 4, and we will multiply it also by 6. We will get that 4 times 4 plus x equals to 6x. Okay, we multiply this equality by 4 and then by 6, and we got that 4 times 4 plus x equals to 6x. We will open the brackets and we will get that 16 plus 4x equals to 6x. We will subtract 4x from this, from equation number 3, and we will get that 16 equals to 2x. We will divide this equality by 2, and we will get that x equals to 8 units. X equals to 8 units. Exactly what we have already found out in method number 1. So x equals to 8 units. So we can write here that x equals to 8 units. That is to say, EC equals to 8 units. Okay, so that is the final answer to the question. So now I will summarize the lecture. Actually, we wanted to find out the value of x. We found out the value of x in 2 different ways, and in the first method, we use the rule of angle bisector. Actually, we use the rule of angle bisector in both methods, in method 1 and method 2. Okay, the rule of angle bisector is that if you have a triangle ABC that can be any triangle, this triangle can be any triangle, and you have AD actually divides angle BAC to 2 equal parts. Okay, theta and theta. Therefore, if you have angle bisector in any triangle, then the following relationship exists between the sides of this triangle. AB over BD equals to AC over DC. Again, if you have angle bisector in triangle ABC, then the following relationship exists between the sides of triangle ABC with the angle bisector AD. AB over BD equals to AC over DC. So we can implement the rule of angle bisector in our drawing, because if we focus on triangle BAE, we know that AD is angle bisector. Why AD is angle bisector in triangle BAE? Because it divides angle BAE to two equal parts, alpha and alpha. Therefore AD is angle bisector. And according to the rule of angle bisector, we know that the following relationship exists in triangle ABE with the angle bisector AD. That is to say, AB over BD equals to AE over DE. Okay, in the right triangle ABE, because we have angle bisector AD, AB over BD equals to AE over DE. Okay, here we divided this equality by AE, and then we multiply it by BD, and we got that AB over AE equals to BD over ED. But we know that BD equals to 3 units and DE equals to 4 units. So we substitute BD by 3 and DE by 4, and we got that AB over AE equals to 3 over 4. Okay? So we know that AB over AE equals to 3 over 4. Then we defined AB as 3K. That is to say, AB equals to 3K according to our definition. So we can substitute AB by 3K in this equality. We substituted AB by 3K in this equality, and we got that 3K over AE equals to 3 over 4. Here we multiplied this equality by AE, and we got that 3K equals to 3 over 4 times AE. Then we multiplied this equality by 4, and we got that 12K equals to 3 times AE. Then we divided this equality by 3, and 12 over 3 is 4. So we got that AE equals to 4K, and according to our definition, AB equals to 3K. Okay? Then we continued to focus on the right triangle ABE. According to the Pythagorean theorem, in the right triangle ABE, the square of the hypotenuse equals to the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared plus BE squared equals to AE squared. Again, in the right triangle ABE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared plus BE squared equals to AE squared. But we have already found out that AB, we defined AB as 3K. AB equals to 3K according to our definition. And BE equals to 3 plus 4, that is to say to 7. So BE equals to 7, and 7 squared is 49. AE equals to 4K. We have already found out that AE equals to 4K, so we can substitute AE by 4K. So AE squared is 4K squared. So here we have 3K squared is actually 9K squared, plus 49 equals to 4K squared is 16K squared. We subtracted from this equality, we subtracted 9K squared, and we got that 49 equals to 7K squared. We divided this equality by 7, and we got that K squared, 49 over 7 is 7, k squared equals to 7. Then we took a root out of this equality, and we found that k equals to the root of 7, the positive root of 7, because k is the side of the triangle. It can never be negative, so it is only positive, the positive root of 7. So we found out that k equals to root 7, so we know that AB equals to 3k, so we can substitute k by root 7. We substitute k by root 7, and we got that AB equals to 3 times root 7, and AE equals to 4k, so we can substitute k by root 7. We substituted k by root 7, and we got that AE equals to 4 times root 7. So we found out that AB equals to 3 times root 7, and AE equals to 4 times root 7. Then we focused on triangle ABC, the right triangle, triangle ABC. In the right triangle, triangle ABC, we know that tangent 3 alpha equals to BC over AB. Okay, tangent 3 alpha equals to BC over AB. But what is the value of BC? BC equals to 3 plus 4 plus x. That is to say, BC equals to 7 plus x. And okay, BC equals to 7 plus x, and what is the value of AB? We have already found out that the value of AB is 3 times root 7. So the value of AB, the value of BC is 7 plus x, and the value of AB equals to 3 times root 7. So in total we got that the value of tangent 3 alpha equals to 3 plus x over 3 times root 7. Okay, and then we focused on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that tangent 2 alpha equals to BE over AB. Okay, tangent 2 alpha equals to BE over AB. BE equals to 4 plus 3, that is to say to 7. BE equals to 7, and AB equals to 3 times root 7, that's the value that we have already found. So the value of tangent 2 alpha equals to 7 over 3 times root 7. And then we focus on the right triangle, triangle ABD. We know that tangent alpha equals to BD over AB. Tangent alpha equals to BD over AB. But we know that BD equals to 3 units. It is given us in the question. And AB, we have already found out that AB equals to 3 times root 7. So BD equals to 3 and AB equals to 3 times root 7. So in total we got that tangent alpha equals to 3 over 3 times root 7. So we actually found out the values of tangent 3 alpha, the value of tangent 2 alpha, and the value of tangent alpha. Okay, but we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha. Okay, and in order to calculate the value of tangent 2 alpha plus alpha, I presented to you trigonometric identity of tangents A plus B. Actually, tangents A plus B equals to tangents A plus tangents B over 1 minus tangents A times tangents B. So we found out the value of tangents 2 alpha plus alpha according to this trigonometric identity. Actually, the value of tangents 2 alpha plus alpha equals to tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangents alpha. So here we substituted in this equality, we substituted the values of tangents 3 alpha, tangents 2 alpha, and tangents alpha by the values that we have already found out for tangents 3 alpha, tangents 2 alpha, and tangents alpha. Okay? And we got, after we substituted the values of tangents 3 alpha, tangents 2 alpha, and tangents alpha, we got this equality. And here we actually made the simple calculations. We have here one equation with one variable. The only variable in this equality is x. So it is very simple to solve it because it is one equation with one variable. Okay, after we made the calculations here, we found out that the value of x is actually, the value of x is actually 8 units. Okay, the value of x is 8 units. So that was the first method to find out the value of x. Then we found the value of x according to a second method. We found out the value of x according to a second method. Actually, we extended side BD by 3 units, and we defined this point as point M. So MB equals to 3 units according to our construction, because we extended BD by 3 units. So MB equals to 3 units, that equals to BD, that also equals to 3 units. So here we calculated the size of angle AMBA according to the rule that the sum of the angles on a straight line equals to 180 degrees. Actually, MD is a straight line. MD is a straight line, therefore the sum of the angles in any point on the straight line equals to 180 degrees, and especially the sum of the angles on the straight line MD must be at point B must be equal to 180 degrees. So here what we have at point B, we have 90 degrees plus the size of this angle must be equal to 180 degrees according to the rule that the sum of the angles on a straight line is equal to 180 degrees. Okay, so 90 degrees plus the size of angle ABM must be equal to 180 degrees. Here we subtracted 90 degrees from this equality, and we got that the size of angle ABM is 90 degrees. So this angle ABM equals to 90 degrees. Then we actually proved that those two right triangles can go into each other, because we have MB equals to BD equals to 3 units. Those two sides are equal to each other according to our construction. BM equals to, or MB equals to 3, and BD equals also to 3, so they are equal to each other. And we also know that those two angles are equal to each other, they are right angles. I've already proved that angle ABM equals to 90 degrees, so those two angles are also equal to each other, they are equal to 90 degrees. So angle ABD equals to angle MBA equals to 90 degrees, and AB equals to AB. AB is a common side, it belongs to both triangles, to triangle ABD, and AB also belongs to triangle ABM. AB equals to AB. So we actually proved that those two triangles congruent to each other according to side angle side rule. What is side angle side rule? If you prove that two sides and the angle between those two sides in one triangle are equal to two sides and the angle between those two sides in the other triangle, then those two triangles congruent to each other according to side angle side rule. Okay, so those two triangles congruent to each other. Therefore, we can conclude from it that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Again, angle MAB equals to angle BAD equals to alpha according to the rule that corresponding angles in congruent triangles are equal to each other. Actually, triangle AMB congruent to triangle ABD. Therefore, the corresponding angles will be also equal to each other. Okay, angle AMB equals to angle BAD equals to alpha. But because of the fact that this angle equals to alpha, then this angle must be also equal to alpha. And we also can conclude from the fact that those two triangles congruent to each other that AM equals to AD. According to the rule that corresponding sides in congruent triangles are equal to each other. Triangle ABM congruent to triangle ABM congruent to triangle ABD. Therefore, the corresponding sides, that is to say AD and AM, will be also equal to each other. Okay, AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Then we focus on triangle ADC. We know that in triangle ADC, AE is angle bisector. Why AE is angle bisector? Because of the fact that it divides angle DAC to two equal parts, alpha and alpha. Therefore, AE is angle bisector in triangle ADC. And we have the rule of angle bisector. The following relationship exists between the sides of triangle ADC with the angle bisector AE. That is to say, AD over DE equals to AC over EC. Okay, according to the rule of angle bisector, if AE is angle bisector, then AD over DE equals to AC over EC in triangle DSC. But what is the value of AD? AD equals to Y according to our definition. What is the value of DE? DE equals to 4. AC is AC, and what is the value of EC? EC equals to X according to what is given us in the question. That is the value that we want to find out. Okay, so in total regard that AD over DE equals to AC over EC, it is to say Y over 4 equals to AC over X. We multiply this equality by X and we got that AC equals to Y times X over 4. That is equation number 1. That is the value of AC according to equation number 1. And then we focus on the big triangle, triangle AMC. We know that in the big triangle, triangle AMC, AD is angle bisector. Why AD is angle bisector in triangle AMC? Because of the fact that it divides angle MAC to two equal parts. That is to say 2 alpha and 2 alpha. Okay? AD divides angle MAC to two equal parts, 2 alpha and 2 alpha. For that reason, AD is angle bisector in triangle AMC. And we have the rule of angle bisector. According to the rule of angle bisector, the following relationship exists in triangle AMC with the angle bisector AD. That is to say AM over MD equals to AC over DC. Again, AM over MD equals to AC over DC. Okay, in triangle AMC, AM over MD equals to AC over DC. But AM equals to Y according to our definition, so we can substitute AM by Y. MD equals to 3 plus 3, that is to say to 6. So we substitute MD by 6, AC is AC, and what is the value of DC? DC equals to 4 plus X. Okay, DC equals to 4 plus X, so we substituted DC by 4 plus X, and we got this equality. We multiplied equation number 2 by 4 plus X, and we got that AC, according to equation number 2, equals to Y over 6 times 4 plus X. But we have already found out in equation number 1 that AC equals to Y plus X over 4. So we got equation number 3 that AC equals to AC. And we substituted AC in this side of the equality by the value of AC from equation number 1, and we substituted AC in this equation number 3 by the value of AC from equation number 2. Okay, and we got this equality. Here we can divide this equality by Y because of the fact that Y can never be 0, because Y is the size of side of a triangle. It must be a positive number. It can never be 0, so it is allowable to divide this equality by Y. Okay, after we divide this equality by Y, we got this expression, and we multiply this expression by 4 and 6, and we got this equality. We open the brackets here. 4 times 4 is 16, 4 times x is 4x. Here we subtracted 4x from this equality. Here we divided this equality by 2, and we got that the value of x is 8 units. Again, the value of x that is actually equals to EC is 8 units, so we found out in 2 different ways that the value of x is 8 units. Okay? Thank you very much.